The majority of issues you will experience with HSRP will relate to the wrong router forwarding traffic for you. You want a certain router to be forwarding. So let's say we have this particular topology right here. So let's connect everything up in our topology. So we're all connected here. Right now, this router is the active router, and this router is a standby router, but that's not what we want. We want this router to be active. So why is it not the active router? That's what you're going to have to troubleshoot the majority of the time. One of the reasons might be preemption is not enabled. In order for a router to become the active forwarder, it needs, one, a higher priority, and two, it needs to have preemption enabled. Because preemption tells a router, if you have the higher priority, you are active. You will take over that role, regardless of somebody else being the active router, as long as you have the higher priority. So it's important to have the priority set correctly as well. So these first two go hand in hand. Higher priority and preemption enabled ensures that the routers you want to be active will be the active forwarder. So you're going to have to be able to verify that information and realize, oh, that's the reason why this one's active right now. Because I forgot to set preemption. Even though this one has the higher priority, it doesn't have preemption enabled. Or maybe, oops, I left this as a priority of 100 and this one's 110. That's why this one's the active forwarder right now. So being able to verify those is very important while troubleshooting HSRP. The virtual IP address has to be accurate, meaning that this router needs the same virtual IP address as this router. If you make the mistake and accidentally configure them differently, you will be notified about that via syslog messages, because the hello packets going back and forth will realize that. It'll be like, whoa, that router is using a different virtual IP than I am. So you'll be notified about that. But the issue we run into is that if you are not monitoring your syslog message, or you're not proactively keeping track of what's going on in the HSRP environment, and let's say this is the active forwarder, and that's what we want. It currently is the active forwarder, and this is standby. But the standby router has the wrong virtual IP address. If this device fails, this router will still fail over. It'll still take over. And as a result, traffic will not flow anymore out of the network, even though it's forwarding. And the reason why is because the clients are configured with the virtual IP address that was configured on this device. So let's say it was 10.1.1.62. And this was actually configured for 10.1.1.61. Well, the default gateway here is 10.1.1.62, not 10.1.1.61. So therefore, we're not going to be able to successfully forward traffic. So even though it failed over and it's the active forwarder, traffic is not going to be forwarded for the clients. In addition, the clients have to be configured correctly. The virtual IP address is the default gateway IP address. So if the client's not configured correctly with that virtual IP address, either statically or via DHCP, then our client will not send their traffic to the correct IP address and MAC address combination, which is the default gateway. When we have a failure here, let's say, or a failure here, or a failure here, or a failure here, then the hello packets cease to exist between the active and standby device. And as a result, failover happens perfectly. However, what if this uplink failed right here? What happens in this particular case? Well, we have a problem on our hands. And that problem is that the client still forwards traffic this way, like this, up to the default gateway, the active forwarder, because it's still active. This is still standby even though this link has failed. So through the use of interface or object tracking, we have the ability to dynamically modify the priority of an HSRP router. So if all of a sudden this interface fails, the priority can go lower, and as a result, the hello packet comes back over and the standby router says, oh, the priority is lower of the current active router, and that means now I have the higher priority and I have preemption enabled, therefore I am the active forwarder. So if for some reason this device is the active forwarder when it's supposed to be to this device, and the hello packets keep going back and forth and everything seems okay, start looking at the uplinks. Start looking at interface or object tracking as being the reason why the wrong device is currently the active forwarder in the topology. versions. We have HSRP version 1. We have HSRP version 2. They're not compatible at all. So if you configure version 1 on one device, version 2 on another device, you're going to be troubleshooting the reason why. You have 2 active forwarders for the exact same group. The great thing is you'll be notified via syslog messages. You'll clearly see that you have a problem on your hands in regards to the HSRP versions. And you'll be able to notify or identify that based on the MAC addresses that are coming up in the syslog messages, because HSRP version 1 and 2 have completely different MAC addresses, and you need to be able to recognize those MAC addresses while troubleshooting. And lastly, authentication gives us the ability to make sure that we're only going to be successfully forming groups with those routers that can authenticate. And with authentication, you can use key strings or key chains. With HSRP, you can use plain text and MD5. So whatever you're using, you have to be able to verify all of that information and make sure that it's configured correctly on all the devices within that HSRP group. This sample configuration is an excellent visualization of what you should be able to identify while troubleshooting HSRP. First of all, you're looking at the interface that is participating in the HSRP group. It has its own IP address and subnet mask assigned to it. And then from there, the standby commands are used to configure HSRP. This group number is so important. If you forget the group number, then you're configuring HSRP for group 0. And if you specify the wrong number, then you're configuring the HSRP configurations for that particular group you specify. So be very, very careful here when you're configuring HSRP or troubleshooting HSRP that the group number is accurate for the configurations. There's our standby IP address, which has to be the same for all the devices within that HSRP group. There's the priority. Higher is better. Default is 100. Preempt, allowing this device to take over as the active forwarder if it has the higher priority. Authentication is going to have to match between the devices within the HSRP group. In this case, it's just plain text authentication that's being utilized. And then lastly, here's an example of tracking an object. The object is object 90. We can see it up here. And we are tracking interface fast Ethernet 0/24. So simply the status of it. That's what this means. The status. Is it up, up? Or is it up, down, 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 or administratively down, down? If it's up, up, don't do anything. If it's any other of the options we have, up, down, 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 administratively down, down, then decrement the priority by 20. So 110 minus 20 equals 90. So we would dynamically drop the priority of this router down to 90 if this interface is anything but up, up. And as a result, if the standby router now has the higher priority and it has preemption enabled, it would take over as the active forwarder. So you have to be able to analyze the running config. You'll have to be able to analyze other commands as well, like show standby and show standby brief, as you're troubleshooting HSRP to make sure that everything is as it should be.